Okay, welcome students, Swell Academy. Working on today finding inverse functions and relations. First thing we're doing is looking at a graph. Originally we were given this line with the two coordinates -7, -2, 2, -5, and what I did ahead of time is I switched the x and y coordinates to show what an inverse line would look like. Now, what makes a function a function is the idea that it passes some sort of vertical line test. So we made our inverse function here, and it probably should have sloped a little bit this way. So not so much this line here, and you could see it would in fact pass your vertical line test. Now, one way to do this quicker without graphing your line is to just, well, what we did was basically we inverted our purple line to our red graph. So one way to invert a vertical line test is to perform a horizontal line test. And since this purple line passes a horizontal line test, it is a function. So one way to test whether or not an inverse is going to be a function or not is to go through the process of a horizontal line test. So this is an example of one that is a function. Let's look at example one that is not. Now I took this graph through the same process. I flipped my coordinates, changed my x's and y's, I inverted my coordinates, and I was able to redraw my graph. Now notice if I took this green, which is my inverse, this is my inverse graph here. If I took that and took it through a vertical line test, it would fail. So again, the idea was, well, why should we go through the process of drawing the inverse of this line? Why can't we just invert the vertical line test into a horizontal line test? And you could see the two intersections here, and because there's two intersections, this would have been a fail as well. So we could say the inverse of this is not a function. Now the thing to consider here is that the original graph here is in fact a function. It does in fact pass a vertical line test, yet the inverse does not. This is from a graphing standpoint. Now we want to take a look at, okay, and just a plain old finding the inverse of a function. Let's look at something a little bit simpler, like a f of x equals x plus 2. Now remember, a function is an outcome or a y, so f of x is technically equal to y. So we could substitute a y in for f of x and put y is equal to x plus 2. Now an inverse is switching of your x and y, so that's simply what we're going to do. And then to solve for the inverse, we're just going to go ahead and get y by itself again. And here is our inverse. Easy one to consider. This is usually what you'll be putting in as an answer. And just the idea of flipping x and y. Now it does get a little tricky when you're given a square root, but it is the same premise. We're switching our x and y. But one thing we're going to have to consider here is domain. Anytime you have a square root, there's some level of domain, because remember, you can't take the square root of a negative number. And here's your switching of x and y. Here's our solving. Let's just say square root of y is equal to, I subtracted 1 from both sides, x minus 1. And then, well, what we want, just to trace back a little, what we want to do is look here for our domain of x. Now, let me just erase this part here so we can go back and take a look at that before we start working on our inverse. Domain is all the values that x can equal. So if we know that the lowest value y could be, for instance, y needs to be greater than or equal to 0. Y can't be a greater number, a negative number. So let's just say we had 0 for y. Well, we would have 0 plus 1, x equal to 1. So technically our domain for x is that x has to be greater than or equal to 1. And this is where we look. When you have x equals and before you solve, this is where you're looking for your domain. Now we could go ahead and solve for domain here. We subtracted 1 from both sides, x minus 1. And then we want to square both sides to get x by itself, or get y by itself. So y is equal to x minus 1 squared. And this is what we want to put in as an answer for an inverse. Let's go on. If you look, was a plus. We had it greater than a positive. Now, continue on. Now I brought this up because the previous one, I just wanted to go over this real quick for domain. The idea that, okay, y is equal to x minus 5. We're switching. X is equal to the square root of y minus 5. Notice, if y is equal to 0, square root of 0 is 0, then x is equal to negative 5. So x needs to be greater than or equal to negative 5. In our previous problem, now we're looking at a negative number. Simple difference. You'll start to see patterns. You'll probably be able to start punching these in without going through the step of switching x and y. Good question here. A couple more steps, and we have this fraction here. Is a question where you're, okay, same thing, we're going to switch your x and y here. So this is a little different, but it's using the same system. I like that word, system. So we have x equal to negative 3y plus 1 over 2y minus 7. And again, we're trying to get y by itself. A few more steps than usual in this type of problem. 2y minus 7. And so we're going to, okay, and what we're going to do is first realize that this is canceling out. We're going to distribute our, now don't be nervous because there's a 2xy there. I could tell you, I got a little nervous, like, hey, what am I going to do there? So I had to take a little pause and look. And then we're going to subtract the 3y this way and move the 7x this way, let's just say. So we're trying to get the y's on the same side. So let's look at this as, let me shrink this a little bit, 2xy minus 3y is equal to, now actually this is a plus 3y. If we moved it this way, we're adding 3y to both sides. And then if we're going to move the 7x, we're going to add the 7x both sides. So plus 7x plus 1. And then the move here, if we're trying to get y by itself, is just simply to factor by y. So let's take that y out, and you end up with 2x plus 3 is equal to 7x plus 1. And then if this is multiplying to the y, then we could just simply, let's add a different color in here, same colors. We're going to divide both sides by 2x plus 3, divide both sides by 2x plus 3. And then our inverse, f of, or we'll say this was g of negative 1, our inverse is going to be 7x plus 1, 2x plus 3. And again, the idea is, okay, we multiply both sides by 2y minus 7 here. We distributed the x to the 2y and the negative 7. We moved our 7x to the right side. We moved to get our y's on the same side. Then we factored out this y, and they were able to divide this here. So a couple extra steps, but just take it through the system. Another question here, just kind of brought up. We saw these, and what I started doing is just a little quick trick here. Let's just look. So we did y is equal to x plus 1. Then we switched square root of y plus 1. And then we end up with square root of y is equal to x minus 1, because we brought it this way. And then you end up with x minus 1 squared. So what I wanted to talk about, like what you'll start to realize, is that 1, basically the inverse is of a square root ends up being the square, and you end up, if it's plus 1 minus 1. So that's a shortcut that I saw. And then when we look here for our domain, we just recognize that this number here is kind of our domain number. So whatever this number here is what we know. So let's look at this here. I say, okay, well, My answer is going to be x plus 2 squared. I'm just taking this and inverting it, and then my domain is simply just going to be greater than or equal to negative 2. So just add a little shortcut here, but I would advise you to first learn the process and then get through it. And then I just wanted to show you a quick cube root of x, y is equal to cube root of x minus 2, make the switch. It's very similar to the square root, but the difference here is because it's a cube root, technically we're not looking for a domain anymore. And then we end up at y. So, and again, to get rid of the cube root, you just cube both sides, and we get x minus 2 cubed. But no domain in this one. I wanted to bring that up. And you heard the word system a few times. This is an individual called Scott Adams, a famous cartoonist. He once said, losers have goals, winners have systems. And I think that was pretty cool, because if you have a system and you stick to it, it may not result in the thing that you think it will, but it will result in something that you were open to because you stuck to your system. And usually you get a result here, and you would read the cartoon here and maybe get a little chuckle out of it. So thanks for stopping by Swell Academy. Hope this helps, and see you guys soon.